Hi, I'm Fred. Privacy, a focus area on Android, and it's been evolving over the last several releases. The scope of these changes includes updates for users and developers. In this presentation, we'll cover some user-facing changes, but we'll focus primarily on developer issues such as new APIs, behavior changes, and testing. There are several things that drive Android's privacy design. We wanted to give users control on when and how much of their data is shared. At the same time, it's important to provide transparency through the system and in-app UIs. For developers, we wanted to provide some guardrails to help you design your apps such that they only access the least amount of data needed for the use case, or data minimization. In Android 11, we've continued to innovate in areas like permissions, storage, and access to installed packages. We also added some new APIs to help you identify potentially unexpected data usage. Now, let's start with one-time permission. When users are given a choice, they are choosing to share less private data with apps. We also saw that there are apps that request background locations access with no need for it or don't explain why. The result? 1-star ratings like this. So we asked our users, apart from location data, what other types of data are important to them? Based on the feedback, in Android 11, we are bringing users more granular control over users' private data, location, camera, and microphone. And we also are significantly limiting access to background location. Now, you may have this very important question in mind. Well, generally, we don't need to make any changes to your app to work with one-time permission. Well, assuming you are already currently following Android permission best practices. Let's have a look at an example. Let's say we have a messaging app. This code snippet follows permission request best practice, which applies to any runtime permissions. When the user taps on the location sharing button, a few things happen. First, we check if the permission is granted. When this is first run, it isn't. Next, we let the system decide if the app could show an in-context UI explanation. Normally, but not always, the first time the system will consider that it's not needed. In that case, the app requests the location permission. This prompts a system dialog offering the user 3 options. Let's say the user selects deny. Then you receive a callback here. Since the request was denied, you should make sure to explain which functionality within your app won't work because of that decision. In this case, we could show an explanation, for example, in a snack bar to indicate that the functionality isn't available. Android 10 introduced granular foreground and background location permissions. Most location use cases can be done with foreground only. You could just request coarse or perhaps fine location if needed. If background location is really needed for your use case, it's good practice to incrementally request permissions to give users a chance to understand and decide based on context. You should first ask for foreground location. When the user interacts with a feature that requires background location, you could display an optional in-app UI explaining the reason for needing the permission. It is strongly recommended that the UI is shown based on the result of should show permission request rationale API. When your app requests background location permission, the request permissions API will send the user directly to the settings instead of the regular permission request dialogues. It is also important to note that the in-app rationale UI in the middle should include both positive and negative actions where users can deny the request because the settings screen is rate limited. The request permissions API takes a string array of permissions as an input parameter. In your existing code, you may already have a pattern like this where foreground and background permissions are requested together. If your target API level is 30 or above, the app must follow the best practice to request foreground and background locations separately. Otherwise, the API will ignore the entire batch of permissions included in the call. So this is something to keep in mind. If an app hasn't been used by the user for several months, Android 11 will reset your app's permissions as if the user has denied your app's permissions in app settings. No change is needed generally. Just check for permissions before accessing sensitive data. Request if you don't already have them. Also, this will only affect apps with a target API level of 30. Most apps don't need this, but there are certain cases where the users expect the app to primarily work in the background. You could consider using this action to redirect the user to the app details settings screen to toggle auto resets for the app. And now, let's talk about a new support for apps to discover potentially unintended access to private data. Sometimes you may be wondering why your app accesses certain pieces of data. However, that's not always clear. So, what are the challenges? Large apps often have some orphan code, and they may have large teams. Accidental data access can happen. Any apps may use closed-source third-party SDKs. These libraries might access private data without knowledge of the developer by piggybacking on top of already granted private data access. For these cases, data access may or may not be intended, and it's not always easy to identify. Data Access API in Android 11 helps provide transparency to this. Whenever an app calls an API that returns private data, the system calls into a collection handler immediately before returning to the calling code. So the handler can collect a stack trace, for example, to record which code performed the access. Let's look at the API. This shows how to set up a callback for data access through the AppOps Manager class. If you want to consistently track it for the entire app, you can set it up within Application on Create. Let's say you want to localize it to a particular part of your app. You could do it within Activity on Create. Within the callback class, your app will be notified of data access in synchronous API calls. When this happens, you may log the stack trace, as I mentioned. It also works for asynchronous API access. Check out the API reference for more detail. More complex apps often contain multiple features. For example, in a mapping app might provide navigation, explore nearby shopping, and find friend features. In Android 11, it allows for an app to attribute data access to a particular feature of an app. Each of the features may use a subset of private data. For example, the Find Friends feature might not need to use the microphone. Mapping data access to a higher level of abstraction makes it easier to find what features have accidental data access. Further, this will make it easier to explain to the user what private data is used for. Let's see how the API works. To attribute features in your code, create an attribution context and give it a meaningful name that corresponds to your feature. For example, Find Friends. Then, you can pass the context to an API call. Within the callback, you can recover the attribute through the attribute tag variable. Then you can, for example, track the attribute within your analytics solution and associate a particular feature with the private data access. Foreground services are usually used to implement ongoing tasks such as downloading large files. There are battery implications, and you should use them judiciously. To provide better accountability for apps to access private data in Foreground service, the platform relies on Foreground service type attribute in the manifest. The attribute was introduced in Android 10. There were a few defined types in the OS. Apps can declare their intentions to access this information within their Foreground services. One of the enforced types is location. In Android 11, there's a couple of new types, camera and microphone. Since Android 9, apps can no longer access the camera and mic in the background, so for quite some time, this can only be done in the foreground. If your app targets Android 11, it additionally needs to declare the new types, or else the Foreground service cannot receive related data. Here's the manifest entry for the camera type. If the Foreground service needs to access different data, you can declare them together like this. To recap, on Android 11, if you need to use a Foreground service to access any of this data, you must declare the corresponding Foreground service type in the manifest. To provide better accountability for access to installed apps on a device, Android 11 includes some changes to how apps can query and interact with other packages. For several common scenarios, you don't need to make any changes. Let's have a look. If you target Android 11, you can still use this Package Manager API to get the package info for your own app, as expected. Now, This API will return only the calling app and certain system packages such as the media provider that implement core Android functionality. If you send an implicit intent for another app to take action, for example, use the image capture intent to take a picture using the pre-installed camera app, in this scenario, another app calls your app's content provider and expects results. Without making any changes, your app can query and interact with the requesting app. Besides the scenarios we just discussed, by default, your app will return name not found exception regardless of whether the specified package is installed. Let's go through a few cases and ways to handle them. If you need to explicitly interact with another app, for example, bind to a service, use the new elements in the manifest to explicitly specify the packages your app needs to query or interact with. You could include multiple entries as shown here, or you can do this implicitly through an intent filter signature. The app can now query for all apps that handle an action send intent for JPEG images. Likewise, if your app needs to access another app's content provider, you could specify its authorities like this. In practice, we've found that most apps can easily express necessary package interactions with the declarations we just saw. However, the system also provides a query all packages permission, which would allow certain use cases to read all installed packages. Look for upcoming guidance from Google Play for apps that need this permission. Sometimes, if an app sends a view intent with a certain URL, you may want to take the user directly to the default native app instead of a web browser. If you just did this, your user may get a disambiguation dialog box, not the most direct way. On Android 11, there's a couple of new intent flags that could make this smoother. The first one is called Activity Require Non-Browser. It ensures that the intent is only handled by the default native app. If one isn't available on the device, it will result in an Activity Not Found exception. In the exception handler, you can choose to take over handling the intent. For example, display the URL in a Chrome tab within your app. There's another similar intent flag called Activity Required Default. It ensures that there must be one default app that can handle the view intent. Else, it will also result in the same exception, so you can override the experience for your users. Let's look at a scenario related to sharing a content provider with another app. You should ensure that the receiving app has visibility to the data by explicitly setting the read and/or write URI permissions. To conclude this section, I'm sharing an ADB diagnostic command to verify if your app is impacted by this change. Check it out. Many apps rely on shared storage, so let's talk about that. Before Android 10, there were two classifications of external storage: app storage and shared storage. Any apps with storage permission had access to all shared storage content. This is regardless if you only need to access your app's specific files or those that belong to others. And users know this. In order to better demarcate external storage access, Android 10's scope storage changed this by adding distinction between media files and other documents. Rather than apps gaining access to all files in shared storage, they now only have access to media files by default. In order to gain access to documents which could potentially contain more sensitive data, the app needs to ask the user to grant access specifically to those documents. I've listed a summary of scope storage changes in Android 10 here. From early feedback, developers told us they need more time to migrate, which makes sense. We responded to that by supporting a temporary opt-out via the Request Legacy External Storage Manifest attribute. Android 11 improves upon scope storage in a number of ways. Let's have a look. First, we've made further adjustments to storage permissions. We've also updated the user consent flow for modifying media. You can batch multiple edit or delete requests in one dialog. Let's have a look at the API. You can specify a list of URIs representing the media files that need editing. Then you'll create a pending intent for the write request. Then pass it into the start intent sender for result API, and the system will show a consent dialog that looks like this. Finally, if the user grants access, you'll be able to edit related media files upon receiving a callback. Many apps use the storage access framework for users to select files. there's a couple of changes to it as well. The Open Document Tree Intent action gives app access to a folder structure selected by the user. To better restrict access to only the files you need, your user can no longer access several locations in the document's UI that are considered too broad or may contain files created by other applications. They include the root, download, and app-specific data and OBB folders. Similarly, through the Open Document Intent action, users won't be able to select files from, again, app-specific data and OBB directories. Our general guidance for accessing media files is through the Media Store, because it lets the system better manage file access and is more performant. So in Android 10, direct file path access was restricted. However, many developers told us that this isn't always possible, which we can understand. For example, this is important for apps using third-party media libraries. In response, we are enabling this in Android 11. File path access for media provides a native file-like interface to Media Store to allow apps and libraries to continue using file APIs to access media content. If this is something your app needs, the recommended approach is to opt out of scope storage with the manifest flag on Android 10. That'll give your app a uniform way of dealing with file paths across different versions. You can check out details on storage best practice here. While most use cases can follow these best practices, certain use cases may still need broad access to files on external storage. In Android 11, apps can declare Manage External Storage Permission, which will allow them to request the user to grant them all files access in settings. This is designed to enable specifically use cases such as file managers, backup and restore, or document management apps. Look for Google Play to provide guidelines for apps that can use this permission. We just covered quite a few privacy improvements and best practices. Android Privacy is designed to offer better control, transparency, and help developers use data responsibly. If you want to learn more about building privacy-friendly apps, check out our resources here. Thank you.